and also the new design. And in the meantime, we have to be able to comply those safety, security requirements, right? You're talking about the ISO 9000. If you are in the automotive business, then you're talking about IATF 16949. You're talking about APQP, PPAPs. So all kind of things, requirements, compliance required upfront. It's up to you or up to the leadership how to make things happen. No matter what you do, we all have to be able to comply those requirements. And the real challenge is for the people like in the engineering, like a team, for somebody to say, I'm wearing a couple of hats, being a leader, in being the engineer, and also being the kind of project coordinators, and need to be able to work all together in an agile manner to make things happening as quickly as possible. So with that, that's what I would like to share with you. How can we make it happen? For somebody to say the faster to market, and really talking about the sustainable autonomous driving, reliability, safety. When we talk about the 6 levels of autonomous driving level requirements, we go through all this roadmap, and really all we talk about the reliability and quality. And the key things, how can we be able to make things happen in the shorter time? And that's really challenging. And with robust design, robust thinking, that really helps our team. And that's exactly what I'm excited to share with you. What can we do? How can we make it happen? Not only from the product development standpoint, especially when you are in a new product development, you don't have too much time to go around with that. You always deal with that kind of challenges. And the question asking yourself, if you are the engineering leader, how much engineering confidence do you have or can you have it? Not the statistical sample size competence. In other words, you cannot afford, because of time and budget, for many sample size, period. And also with the ongoing challenges that many business, if you're not new in the area of a digital transformation action or requirements, or just start beginning, don't tell me you haven't got started yet. But truly, when you have to be able to improve your process, for example, say in a traditional manner, you know what you need to be doing, improve the process of for a manufacturing or supply chain or whatever it may be. You always start with a simple tool, for example, say value stream mapping. When you are able to identify the area, also then you found out that your data is not available, really the data is not visible, and up to the kind of a business requirements that you have to be able to make decision to make a sales or the marketing strategy. But the challenge is, do you have those information from the manufacturing? The answer is like yes or no. So really, the point you make decision for the digital transformation, and before you're doing the digital transformation, then you're really thinking about the digitization upfront, and how you walk all the way through from this area, how to dedicate effort, invest your time, and go through all these things that go and make a kind of the digital transformation, make a kind of AI application, machine learning, and talk about the data visibility, how to implement the kind of automations, and talking about the supply chain, autonomous driving trucks, and how to build infrastructures, all things happening. And that's really what we can learn from it. The bottom line is when you have to be able to improve those kind of a situation, the thinking comes to the picture, because you have so many tools you can choose, you can use it. But one fundamental, critical, essential is that do you have that kind of thinking? Tonight, I want to share more with you about the robustness thinking. Because without having that kind of thinking, you can always jump around. You can do tool one, tool number two, whatever it may be. And especially come to the point of reliability, there's so many tools available for you. And also the reason for the tonight's sharing about the robustness thinking, that's to really solve the problems and really talking about the situation. And then we talk about the challenges in old way, when you have to be able to meet and fit that kind of specification, right? Let's talk about the problem solving. And really, when you have to be drive those defect out, and then you apply using much more formal approach, that for example, say using a Lean Six Sigma DMAIC approach. So when you are thinking about it, and then you asking yourself why you have to be having that kind of a tight tolerance, then you talk about the kind of things. Can we be able to enlarge those those tolerance so that we can be able to fit into that kind of challenges. And really up to a point, and then you have to know when and how those tolerances was established. So the beauty of this robust thinking and robust design, that's that kind of the really technologies agnostic, meaning not sensitive to technology itself. That's make it beauty. In a nutshell, the whole thing is always, can we be able to make things better, faster, cheaper? So in that scenario, you can find all the articles published in that kind of in the Google. You can find it. That's a kind of link. I put it down in my presentation, and later on you can find yourself and then look into yourself. So really, all we are sharing with you up to this point is a why robust design, why robust thinking is all about the efficiency and effectiveness. So with that, really, that I owe you about this definition of meaning of a robust design. Let me start with a popcorn story that how many of you here have not tasted popcorn? So if you say yes, that means none of you have not tasted popcorn yet. Just imagine the old way, if you have not good taste of popcorn, what do you do? It's really very simple. You figure out a way to solve the problems, right? And then standardize those kind of experience. Then you can make popcorn again, make it better. However, those popcorn making experience in old traditional way is very sensitive to the experience. If you are not in the field of a popcorn business, for example, you and me or the kids or the senior people, you don't know what to do, how to make the popcorn. What does that mean? That means that kind of popcorn product or technology is very sensitive to the user environments like you and me who have no experience. So really, that's kind of tough challenge. So in that kind of challenges, what can we do? And certainly we have not that kind of technology and product already. Think about today's popcorn and microwave popcorn, and really that we know well. It doesn't matter what age you are at, how much experience you have or you don't have. You just simply put the popcorn back in the microwave, and then you simply get the turn on the microwave. That's the 4 or 5 minutes. Then you can have a very good taste of popcorn. You don't have to worry about experience, right? And then your expertise. That's really kind of a mindset of a robust thinking in our tonight sharing. And that's really that's happening in all kind of technology applications, especially in the problem solving or in the product development, and talking about the continuous improvements or the operational excellencies, how to improve the business excellence. And that's all about it. Certainly, robust thinking is one of the essential thinking in our today's sharing. And I have the privilege to working with the Dr. Junichi Taguchi, and also working with him advance his methodologies of robust parameter design to the sense of a robust concept designs. And I have studied the kind of engineering and get the PhD in the industry engineering under the Dr. Junichi Taguchi's guidance. So was able to help organizations improve the problems solving, especially improve the industrial challenging problems. For example, it's in the kind of aerospace or helicopter designs, aerospace design, automotive designs, and really that thing gave me tremendous that kind of experience to share with you tonight. And how can I be able to help and share my best practices with you? And also, I'm also teaching at the University of Houston to offer the robust design solution and to bridge the gaps between the students and the industrial professionals and faculties together to develop that kind of robust solutions, improve our competitive challenges in the sense of a robust product, robust technologies, and also the robust supply chain strategies. And that's really what I'm doing. So having said so much about it, and really I would like to share with you about the sense of robustness thinking. Let me start asking these questions. Will your customer always use a product under the best conditions? Or will your product always be manufactured under the best conditions? If you're asking yourself this way, the answer is maybe no. And absolutely, if you got the answer, congratulations. Absolutely no. And simply because the variation happens all the time, that means that all things we're doing is not perfect in the world. The world is not perfect, absolutely, simply because of challenges of variations. If you record a Uber autonomous driving vehicles failures in 2018, that's a really challenges. There are kind of technologies at that time, certainly, even though now not mature enough. But the challenge is that can you be able to learn the limitation of the given technologies at the time? Regardless of what you do, you still have to be able to help organization to create the values by leveraging the new technologies to develop product, right? The autonomous driving vehicles is one of the challenges and lessons learned. If we do not understand the robustness of the vehicles or the products, you simply have nowhere. Certainly, we all know we need to be able to provide the safety and security for the product coming out to the market. Even though you are demonstrating the product itself, you have to be very sensitive and ensure make no mistake about the product safety and reliability. But unfortunately, that kind of a new technology, especially these days, we're talking about the new technologies, all things about AI applications, especially in the autonomous driving business. There were so many new designs talking about the LiDAR, millimeters radar applications. And the question, especially for you and me, or maybe more applicable to your current product and process, can you be able to ask yourself, can you be able to improve really the kind of design the failure mode out? It's simple, straightforward, without talking about robustness. But really, the question is how can be done in that way, in the sense of with a much more engineering confidence. Many tools, I'm sure most of you here attending these questions, I would say you are maybe the professional or expert in problem solving, quality, reliability already. But really, if I could ask you a question, how effective you can performing that kind of tests? The answer may be yes or no, or we don't know yet. That's exactly what I would like to do. Explore the challenges, especially like a Uber case study. If you don't know what you don't know, you end up with that kind of challenges, the safety issues. Let the customer test your vehicle with the kind of failures happening. That's exactly what we don't want to see. It's not allowed it for you and me, especially being in charge of products development or technologies or whatever it may be. The bottom line is how can you be able to deliver the products at the highest quality, reliability at the lowest possible costs. That's the key thing. Think about today, we talk about this reliability. I'm sure most of you here, you know how to spell the term of reliability. And you know well the meaning of reliability. But if we could ask you, what's the meaning of robustness? And that's exactly what I would like to share with you. Just imagine if you are in a new design, for example, it's a helicopter. I had one experience when I was engaged with the team designing a helicopter, fuel metering design. It's a brand new. You name it, there were so many experts out there and especially technical people. They know what they were doing with all the software, hardware, but really when they launched the kind of vehicle testing, the helicopters went down. Can you believe it? Unfortunately, that's a fact. But really, if you're asking people know well in the team, knowing very well about reliability approach, absolutely, you bet. There were a whole bunch of reliability experts out there. But the challenge is that even though they used or went through all the sophisticated tools, let alone about the simple DFMEA, I'm not saying that's kind of simple, but just comparing with all different tests. When people talk about reliability safety, right? They know what they've been doing. Talking about design for reliability, design for X, whatever it may be. But really, the whole thing, when we were talking about reliability, there's always kind of a lacking effort, right? Absolutely, when you don't have the data, guess what? You don't have analysis done, isn't it? So how can we handle the things? That's exactly kind of a reliability story. So when we compare to the robustness story, later on share with you, that's like what I have shared with you about the popcorn story, the meaning of the robustness is to make your product, process, or technologies insensitive to the user environments. Certainly, the definition of a user environment is very well defined, because I only the definition later on in the 5 different categories, talking about the manufacturing variations, aging, all the way to the design interaction interfaces. And really, you can see in here, the kind of screen, you're talking about helicopter, talking about the autonomous driving vehicles, talking about today's Internet of Things. And really, if you're asking yourself, sometimes at home, your modem kind of internet connections are not always reliable, isn't it? If you think that things are very complicated, I don't know what's going on, but let me share one case study with you, talking about simple mechanical print connections. And that is the kind of case study for you and me. I'm sure you're very well at problem solving. But if I am asking you now, if you are given the challenges for such simple case, just simply that the couple strands and terminal got disconnected, how can you fix the problem? And even more further, if you can learn from the lesson, how can you design this kind of product in much more advanced manner, meaning with a high reliability at the lowest possible cost? And that's really a case study that was happening in 1996 in the automotive supplier, when they were faced a kind of a 200 million safety recall. You may not believe it, but that's for a fact. You can Google it, you can find it, that kind of stories. But the reason I'm sharing with you, because I was involved in that kind of challenges. Being a reliability engineer or specialist, I was given the tasks. And when I was investigating that kind of challenges, you will be surprised or not surprised, all the tools they've been using, even though now all the team, they use it, they did it. So you may be thinking, what am I talking about? That's exactly what I'm keep the cats in the back and asking you, help me out understand what's going on. But I do want to share with you the whole story and share with you about the story about robustness. And so go back to the way we are approaching reliability. Let's talk about unreliability first. When you are seeing this screen, then you talk about the bathtub curve and talk about the manufacturing failures, right? And whenever we're talking about how you can be able to prevent the kind of manufacturing failure upfront. And also at the usage variation, the best period, the constant failure rate, and talk about the wear out period. So how can you handle that situation like this? And I'm sure you have lots of good experience and also success or unsuccessful story and share with us. And just imagine from the upfront design all the way to the end of the product, end of the products cycle. I'm sure you have a lot of tools been through it. For example, say the control methods, the tools, and the bathtub curve. I'm sure most of you here know very well. For example, say in the infant mortality phase, you have a lot of tools and talking about robust design, DOEs, talking about DFMEA, cyclical tolerancing, or the Hall, the HAS testing. There's so many tools, the testing strategies, you can name it, you can use it, right? And even though in the useful life, I'm sure most of you know this well, very well, it's not new to you. And wear out life, there's so many things talking about this, the software packages, talking about the whiteboard analysis and whiteboard plus, and talk about the liability software. So many packages out there available. But really, those things are good tools. It's up to you where and when, how to use it, so that you can be able to have or increase your engineering confidence. Now, keep in mind, in the upfront product design, you have no idea when you are dealing with the new technologies and new design. And really, how can you deal with the reliability? I would love to learn your story. And secondly, when you are in a situation doing the problem solving, and then you can find those problems again. I'm not discounting anybody's good efforts for problem solving, but unfortunately, when those problems irritated a couple of times, still having the same challenges, although those experts are rewarded as kind of firefighter hero, but yet the problem was not resolved. Why? And that's really kind of thinking behind the reliability tools that I'd love to share with you. The challenges of reliability theory assumptions upfront, as a matter of fact, you and I, if you are working in the area of product design, reliability engineering, or the quality or supply chain, right? Then all the reliability models and assumptions, and also talking about the processes under the stable process control. And in that kind of assumptions ever be true. Lacking indicator for reliability performance, talking about the reliability accumulation study, talking about performance testing, whiteboard analysis, all those are very well efforts. Minimum 3 sample size, a minimum, right? All the things, that's what we have been doing. And the much more challenging is that sometimes we have no clue for the root causes. Why? Can we do it better? And let's review again about this reliability and robustness approach. And really, the reliability and robustness is very effective engineering measure of reliability upfront. The robustness is a leading key performance indicators. If I could ask you now, how many of you have heard or used in your current business using the robustness as a measure or as an effort to improve the ongoing product design or the process design or the continuous efforts? If you done that or you have it, congratulations. But in general, based on my observations and my collect information, very few of them. I mean, on top of those exercises, I know for sure that the top notch of the automotive business, especially the T1 suppliers, I know for sure they know very well. But for the people, for the business outside of the automotive, for example, the oil and gas, or even though sometimes the electronics, for example, I'm sure they have a lot of sophisticated methodologies, very specific, tailored to the special business, for example, the PCB board, right? And all things are good. But yet the fundamental challenge is asking yourself, when you are or when we are talking about reliability, what we are talking about specific. You don't want to wait until you have a couple of sample size or large sample size so that you can get enough critical sample size confidence. Really, at the upfront, if you are the engineer, I've been there, no. All I have to do is to kind of make the product design first, so functional happening, right? And then test it out and knowing where we are, and I don't have too much kind of knowledge about it. And really at this point, come to the specific, very hands-on experience, talking about the robustness. Its ability of a product to perform its intended function consistently in the presence, now let me be more clear, in the presence of uncontrollable user environments. The question for you and me is that what are we talking about the uncontrollable user environments? Are we talking about the same thing in the sense of reliability definitions? The answer is yes and no. Especially when you're talking about reliability, always talking about the density function, where when you are dealing with a new design, or even though you change the design, you change the physics already. You don't have the luxury. So that's the really challenging in the current practical exercise. And more is that today, when we're talking about, if I could say, what can you do? What can we do better? And really very simple. Back to the basic, what with the failure mechanisms and their relations to the variations. Now the question is that, what are we talking about variations? How do we know? Well, that's kind of the challenges and all the strategies and our best practices we'd like to share with you. In the sense of reliability in the world, and variation is everywhere. Life is variations. The reason we got the failure modes, that's because of variation. We got deviations, disturbances, noise. For example, today is the kind of supply chain challenges, disruptions, always noise and disturbance in the kind of the uncontrollable user environments. So having said that, how can we be able to make things happen? And the one question as to what we define about the meaning of robustness, where it's talking about this, the insensitivity. And that comes to the point I would love to share with you about the Dr. Junichi Taguchi's definition about robustness as a state where technology's product or process performance is minimally sensitive to factors causing variability at the lowest possible costs. Now, keep that definition in mind. Really, very simple. If you are out of today's presentation or sharing, you got an idea about the definition of robustness. It's really about insensitivity to the uncontrollable user environments. So with that kind of concept thinking in your mind, let's also go back to the case study I would love to share you and love to learn your thinking. As a matter of fact, because the webinars are hard for me to have that kind of interactive communication, but I'd love to learn a question you may have for me later on at the end of presentation. But let me ask you questions. For this kind of a simple mechanical connector design, how do you design the reliability? As a matter of fact, let me pause it here. I'm sure a lot of things you're thinking in your mind. Well, you may think about that's very simple, right? And do that kind of a tensile testing and make sure it holds certain strength and kind of certain force, right? And do that kind of simple DFMEA, maybe very simple, or process FMEA, and do a test and that's it. It sounds very simple. It is very simple, but life is not as simple. Let's review for the conversation purposes today, talking about the typical design for reliability process used by companies. As general, by no means is the kind of a very detailed, but in general, most companies using that kind of process, if you will. If you are in a much more well-organized organization, you may have a process similar like this one. They talk about the concept phase, and talk about the design phase, and talk about manufacturing phase, support phase, right? And really, that's all kind of tools. You name it, you have it, you can use it. And I don't discount all the good benefits of this kind of tools, right? But the question for you and me is that how much engineering confidence you can get from that kind of tool applications. For example, say, let me use one question for you. DFMEA. I'm sure most of you have been using DFMEA for a long time. If I could say that's not something new to us for tonight's communication, especially the all of you here, let me ask a way. How do you use the FMEA to improve your engineering confidence, especially when you're dealing with a new design or new technologies? If you say you have learned tremendously, I would love to learn from you and see how you can get more engineering competence. Certainly we could get some engineering competence, but the challenge of the tools is very limited in the sense of your team experience for the new product, new technologies, especially when you're dealing with something new, you don't know what you don't know. So when you are in a situation you don't know the failure modes, how can you design a failure mode out? Right? So then you have a lot of different approaches, but really kind of thinking upfront, especially when you're dealing with the kind of FMEA or fault tree analysis, talking about the qualitative approach, you're asking yourself, how sensitive your design to the uncontrollable user environments? And that's kind of thinking thought I want to share with you tonight. And so go back to challenges of this simple crimping connector design. And that is the situation we were at, the situation, at the challenges. As a matter of fact, the team for that kind of specific case study, because a huge business for the automotive tier one supplier at that time, they've done the DFMEA, PFMEA hall testing, design of experiments, AD problem solving, whiteboard analysis, standard operation procedures, the SPC, operator training, you name it, they've done it. I would say pretty much about exhausted. If you review today's ISO 9001 requirements, they talk about the traditional way of approaching APQP, right? They did it. But the challenge was that the result, the connectors were still disconnected, failed as unexpected. One of the main reasons that's kind of challenges are disconnected in the field and triggering that kind of safety concern. They have a safety recall, estimated about $200 million. So if you were given or are given the similar situation, what do? Well, that kind of challenges that time of facing was facing challenges. Now, let me share with you a little bit more the challenge, the deficiency of the conventional approach. Let's talk about the design, test fix, right? And also test until the product is okay, good enough. Nobody knows how much confidence you have, suddenly you got some confidence. And really, when you come to a point when time's up, you're going to go up. But really, the kind of pros, the lack of engineering confidence, that's the challenges of a conventional, I would say, maybe traditional approach, right? And let's circle back talking about the design process. And really, in the product design, we are dealing with the four domains, talking about the customer requirements, talking about the functional requirements, talking about design source, that we call design parameters, and talk about the manufacturing process, we call them process variables. And really, from the concept design to the detailed design to the prototype, if you will. And from this process, all we're dealing with kind of huge variations, if you will, talking about the critical to quality, critical to reliability. If we review much more detail in the sense of now it's a much more theory, but the point I'm trying to get across that kind of variability of a design. Really, the variation of a product or process really is not only the pure variation about sensitivity. That's all we're talking about, the sensitivity and also about the robustness in this case. And now you come to the point where when we are dealing with the system variability, we always have to ask ourselves, do we understand that limitation of current challenges or in a sense of technologies and reliability? What are you talking about, Matthew, here? So really, I'm talking about, do we understand the limitation, really sensitivity of the given technologies in the current design? So really, if you don't know this one, then you'll be facing sickening challenges. All the traditional reliability efforts, you name it, that's good, but not good enough. I never discount any great efforts that we have been working on, but challenges, they are not sufficient. And really come to the point with the kind of mindset thinking behind the background. And really, when we are designing this kind of a simple connected design, and all we're dealing with the kind of pole string as a simple, isn't it? I'm sure you know it very simple. But really, when you are in the situation, you don't know what's going on, you cut off the kind of processional wheel, you see that kind of strand and copper, and really talk about this kind of the area, there are a lot of holes, bubbles. And what does that mean? That means that kind of area can capture the moisture. So we did not know, we don't know at all. I wish I knew at that time and helping the team solve the issues. And really, when we were dealing with the challenges, especially in the upfront design, we don't know. There's so many uncontrollable factors in upfront. If we did not know, we don't know, and we did not spend enough time to find this their kind of challenges, then later on those troublemakers will pop up in the field in the customer usage area, and that's the challenges. And that's exactly why I would like to share with you is that when we are dealing with those given design, put it this way, can we be able to excite those failure mode? The really problem solving for you and me is that how can we be able to duplicate the failure modes? It's that simple, isn't it? Before we talk about the problem solving, confirm the challenges. But many of us sometimes we did not know that kind of thing. We thought we fix a problem, but things pops up. And when we talk about those situations, don't get me wrong. I do understand there were so many professionals out there dealing with a lot of robust design reliability theory. Talking about it for some of the deterministic design, right? We're talking about a safety margin. I know for sure in the oil gas business, we're always talking about safety margin, but really, does the safety margin give you the confidence? And the question is a yes or no. The challenge is that do you or do we understand the variations in that kind of definition of safety margin? Because the kind of the name of the game is talking about the deterministic design, right? We're talking about the safety issues, and when we talk about this probabilistic design, then you talk about the distribution of the safety margin for the given mean strength and mean stress, right? When we are dealing with the kind of aging, dealing with the kind of manufacturing piece-to-piece variations, and talking about the external environment, talking about the customer usage, then talking about the system interactions, interfaces. All things are very confusing and mysterious to us if we did not spend enough time to explore the challenges up front. So when you come to a point, you see the design one and design two, which one's much more reliable? And most of the time that we talk about, if you have a large safety margin, they'll be much more reliable, if you will. And really, the answer is not that simple. We have to be able to understand, explore the challenges in the sense of variation. For example, in the case design too, the variation of this kind of mean stress and also the mean strength is huge. So certainly by looking at this one, this is not necessarily reliable than the first one, although they have very smaller safety margin design. And really come to the point talking about the timing and costs, we have to deal with the variations as being challenging. So now, having said so much things, I only a definition of noise factors. We define it for uncontrollable user environments. We talk about the first piece-to-piece variations. That's because the high production rate, and also the change of the aging over time, and the customer usage, right? And also the external operating environments. Last but not least, I think that's the most complicated, talking about the interactions interfaces in the internal design. So really, that's kind of an engineering design responsibility most of the time. That's what we are talking about, the engineering competence. If we did not exercise challenges of our design in presence of those challenges, the chances are you don't have too much engineering competence. Let's talk about the bathtub curve again, circle back, and also map those noise factors in a kind of the robust design reliability, especially in the upfront phase, the second phase, right? We talk about the noise 1, noise 4, 3, 4, 5, and also the aging, the way out. And really keep the things in mind. And the robust design really is kind of powerful too, and the thinking. Certainly, there were so many tools can be called a robust design, but really robust design itself is concentrated on the robust ideal function for the specific technologies and product. Really is to make a product insensitive to the uncontrollable user environments, and they apply the two-step optimization and how you can be able to understand and select the kind of factors so that you can be able to desensitize the harmful side effects of a given design in the sense of noise factors. And then you can optimize the design for most possible costs. So really kind of a robust design principles. But again, before we come to the point about robust design, it's really critical, essential thinking about the robustness thinking. Because I'm sure you have so many different ways of saying robust design. But as for the critical thinking, if you don't have that one, you have no challenges in your mind how to develop deployable robust design strategies. That's exactly what I mean. And I'd love to share with you. Why robustness, again, really is an approach to make money. If you do not, apparently there were many companies out here and the current exercise business, not much want to deploy the well-sound robust design strategies. And here we'd love to share with is a robust design, reduce performance variations, and achieving this Six Sigma quality level quality, and all things you can name it. And also from the time to market standpoint, you can be able to significantly reduce the build test fix strategy, the cycles. And from a supply chain standpoint, you can reduce the kind of variations, especially to different kind of risks of disturbancy disruptions. So come to a point talking about the robust design reliability. We have 4 areas we need to deal with that. Once the minimize the sensitivities, the noise, reduce the rate of a change of a product design, we call tolerant design. And as many of you here know well, redundancies, and also certainly we have to deal with this manufacturing process. But today I want to share more with you upfront the robust design strategies and upfront robust parameter design. And really, the kind of robust design effort is to explore the given design and identify those significant factors to minimize variations of performance. And that's exactly what we're doing. And that's kind of a chart that talking about how to find those factors where can have a minimum variation of performance. That's the area we are looking for from these robust design strategies perspective. And come to the robust design principles, really we talk about the robust engineering and talk about the system design, concept design, and the parameter design, tolerance design, all this related to the reliability, especially talk about this, the design for reliability process. Always you can deal with that. And again, let me be more specific, reminding you, talk about the robustness. How can we be able to use the robustness as the leading indicator to drive the kind of design reliability efforts rather than lacking efforts? Now, come to the point, how can we be able to know that kind of robustness? What kind of strategies behind that kind of robustness thinking? And this is the real robustness thinking model. And really, when we talk about a systems, when we are design systems, certainly we design for function, isn't it? So when we are design a function, really we are dealing with kind of ideal function, right? Let me be more specific, use a motor design. Why do we design motor? Really, the motor design intent is to develop, generate torque and RPM. Very simple, right? And also for the motor design itself, what kind of input energy is really about the current and voltage, right? If you're talking about this motor design. And certainly in the motor design, there are so many motor design control factors, strategies, right? Especially if you talk about today's electric vehicles, right? And they talk about the electric motors, right? So all kinds of things, that design strategies, all talking about control factors. But really, in the most of the time, although we know we can be able to generate the design functionalities based on the design technologies and the combinations. But one thing, when we come to the point dealing with the reliability and quality, how can we handle from this standpoint? It's not the point up to us to necessarily to explore those failure modes when we do not have enough experience, especially in the new design, isn't it? For example, say the new motor design. Every new motor design is a new engineering combination challenges. And the one thing for sure is that if we can be able to explore those uncontrollable factors in those 5 different categories, absolutely, we can be able to help us out to plan and deploy the kind of noise strategies, how to manage the strategy, so that we can be able to optimize design by optimizing the design parameters, so that performance variations not sensitive to these troublemakers. And that's exactly kind of robust thinking. So with that kind of thinking, you can always take all kinds of different tools come into the picture where you can be able to apply to earn that kind of engineering confidence. For example, you can use in kind of many testing strategy, optimizing strategies, including these AI, machine learning, deep learning, that kind of strategies. So that's kind of we call the P diagram for the robust thinking model. And really the whole idea is that if the systems are perfect, always the 100% energy in, you can see always 100% energy out. But unfortunately, this world is not perfect. You don't get 100% out always. So really it's up to you and me how to explore the challenges of troublemakers creating that kind of error states. We call it symptoms, if you will. So that's kind of robust thinking. So let's circle back with the kind of our live case study, talking about this, the crimping, connector crimping problem solving. Come to this problem solving, the team was not knowing what is going on. Really, they didn't explore the challenges, especially cut off the kind of the cross-sectional view. And they thought they could be able to make the reliability happenings by simple do testing, as long as they can have the kind of enough pole strength. That's all you need. But unfortunately, the team was not aware of the voice bubbles capturing the moisture in the voice and bubble in between the kind of the copper strands. And that creates a kind of the rusty and also the loosening the kind of bonding efforts. And certainly that's kind of later on, and I wish the team, including myself, would know upfront. But certainly we did the whole effort. We helped the team improve the kind of robust design strategies, mandatory upfront as the kind of design criteria. And really in the simple, in the kind of study, when we are doing that kind of the product design, and if we think hard about the design intent, really this design intent is about these two characters. One is kind of pole strength, another one's the kind of these conductivities, and really that kind of design intent. The reason we make that kind of connected design, the conduct is a current or energy flow, if you will. And certainly the second, I would say, that's even though the support function, but primary for support function. And they talk about this, the pole strength. So in that scenario, is that the challenge for the teams that you cannot crimp this too much, because if you crimp this too much, although you may have good pole strength, but you increase resistance. So you have a kind of the voltage drop too much. That really, that's what was happening in the past, that the team did not do that kind of robust design effort, that they thought the one solution would be good as long as they maintain a good and effort to see the high reliable informations. And really, and the team later on found out that's not the case. Now they see a two performance output as a measure from a design perspective. How do you deal with that? So come to the point, the team really talking about the input energy and the output energy. And when you have the kind of ideal function, right? In the sense of the pole strength and also the voltage drop, then you need to be able to figure out how to optimize the performance. And really, that kind of in the sense of understanding what's going on, that we use the signal to noise ratio to measure the robustness, the design output, and harmful outputs. And with that kind of thinking, the team was able to resolve the problem successfully. And one stone killing two birds, and we improved the engineering competence successfully. It's really talking about how to understand the design options, limitations, and let the design exposure under the noise factors, and how to evaluate the success, how to be able to distinguish the differences or distance from the failure modes, but let's say from this ideal function to the failure modes. As a really, that's what the team was done. And from this, the robust design mechanics improve the reliability successfully. And really, that's kind of a traditional reliability demonstration using the whiteboard analysis. That's what we call the crimped connector reliability demonstration plan and report. And that's kind of very traditional way of doing it. But having said that, really, the one thing we don't want to forget is that the upfront, how we can take the advantages of robust thinking and apply robust design, improve that kind of the robustness before talking about reliability at the lowest possible costs. So really, that kind of sense of engagement, the team successfully resolve the problems and significantly without increasing costs, without introducing a new technology, for some say fusion technology. So we did not use that one so successfully. So we talk about the rules of robustness, really a kind of a concentration on ideal function, and all the way to the 11. I'm sure there were lots of interest in the sense of how to handle this one. That's the kind of thing, because of time concern, I'll share with you in this kind of simple efforts. Certainly, you're welcome to ask me questions much more detail later on in the Q&A sections. And having settled down that kind of a simple case study, in the sense of robust design, robust thinking, robust design. The second case study I'd love to share with you, the robust thinking in an innovative problem solving. And this is really a design for Six Sigma case study. It was a case study from Ford Motor Companies called the hydraulic latch adjuster design. Well, this design really was happening with the kind of birth defect designs. So when the customer, especially end user like you and me, in the field, when you hear a lot of morning sicknesses, it's simply because the engine having that kind of noise up front, and you don't know how to deal with that. As a matter of fact, that the supplier was in the business for at least 35 years. And every time they spend the effort to solve it and they claim success, but the problems kept coming back. And that's the challenges. And really, when we took these challenges and we examine all the team did, and we found they did an excellent job, but just did not solve the problem the way it's supposed to be. And really, the challenge, the root causes was that the air captured the kind of oil. And when the air captured the oil in the hydraulic latch adjuster, and the air can be compressible. So that creates a kind of high speed, you can rocket arm running and destroy the kind of the components. That's what happened. What happened in that kind of the study. So at that time, the team was not aware of those air was capturing. Well, they know that air was capturing in the oil, but they thought the whole exercise could be compensate each other. I mean, they did not even worry about what to do with the kind of air in the capturing in the oil. So when we review the whole thing, we found out the design deficiency were there for air capturing the bad looping in kind of the systems, never be able to get out of the kind of oil. So that's what happened, the problem. So really, from conceptual standpoint, we create a kind of new design, and the team found a pattern to solve the problems. Really, we simple create a kind of oil path for leading out of the air. They're successful with this kind of concept design. And really, once the team come to a point, create a new concept design, and come really later on, we're talking about the robust parameter design. Really, in that kind of detailed design, we apply the robust parameter design. So we are very successfully create a kind of reliable product designs. Very successful. You see, that's kind of performance before, very sensitive to the air capture in oil. Later on, there's no such sensitivity at all. Very less variations. So this project helped the organization, at least for this project, at least $689,000 for the project alone. Now, I haven't counted in the accumulated kind of years accumulation for cost saving year after year. It's a significant saving. And then we improve the process capability from this 1.34 to 2.89. So really, the kind of case study, very successful. Now, when you talk about really successful, doesn't matter talking about design for reliability or design for Six Sigma. The bottom line is that, do you have that kind of robustness thinking? And that's essential, critical. If you don't have that kind of thinking as essential, you're always trying to find out all the simulations, all the kind of CAD, all the sophisticated tools. There's nothing wrong with that. But really, how can you be able to, with that kind of thinking, develop the kind of strategies, challenge design with us a given noise factors environment to improve and increase your engine confidence? That's the bottom line. So with that, the important takeaway from this sharing tonight is all about robustness thinking is essential to improve quality, reliability proactively. Nothing can be substituted for thinking. And certainly tonight, and we focus on the thinking alone, because when you are talking about tools, there are so many tools out there available. Secondly, take action for robust design as approach to agile product development and achieving the competitive advantages, and make design insensitive to the upfront uncontrollable user environments. And always early deployment of robustness is a key to proactive quality reliability improvements, and apply the robust design principles at early design phase to forecast the problems and take the preventive action and build a predictive product, process, and technologies. So that's the kind of key takeaway. And with that, how can we get that kind of robustness thinking and robust design strategies? And certainly you can go search at Google and learn yourself. And certainly your corporation may have the opportunity for you to learn the classes. But one thing I can share with you is that certainly you can go take that kind of robust design course at the University of Houston. We have that kind of robust design certificate program for both robust design and design for Six Sigma. And certainly you're welcome to sign up, and 3 days or 5 days for the kind of training. And you will be giving this the University of Houston's certificates granted by the university. They're much more formal, and you can earn the credits. And so then you can go to ASQ. There were so many good training tools, certification, right? So with that, let me stop here. Questions?
Thank you, Matt. Doctor, there's a couple of questions. One is for Wei San. Wei, do you want to unmute yourself? Well, everybody can unmute yourself. And Wei is asking about.
Yeah, so
Wei,
my question.
Oh yeah, go ahead, please.
Sorry. My question is, in one of your slides, you have a formula like y is a function of x1, x2, x3, and so forth. And then you have a formula like the sigma of y is equal to square root of something, right? So I assume that's derived based on the assumption that you use Taylor. Yes, exactly. This formula. So you use the Taylor expansion, you drop the higher order term. That's my assumption. So, but for that to work, you need to assume that these x1, x2 changes by very small amount. So my question is, what happens if that's not the case? Sometimes x1, x2 can change by a large amount. One simple example is when you design a circuit, the capacitor. So if you look at capacitor, the capacitance has a tolerance band of plus minus 30%. So what do you do in that case?
Well, I mean, you're asking the great questions. Really, the formula shared with you when we are dealing with the system variability, right? And certainly, if you are an expert in the capacitor design, and you know design solutions already, the questions that when you are dealing with the failure modes or underperformance design, and really, if you are talking about the design parameters, so which design parameters is significant impacting your performance? Really, then you're dealing with that kind of specific. Sometimes you may know, sometimes you may not know because you did not deal with the product upfront to know enough about the knowledges. So in that case, that you really to design the strategies and really what is the noise factors happening to your performance. For example, it could be the manufacturing strategies, or maybe the application environments and the chemical process or whatever mechanical process that creating kind of interactions. And really, that's the point I'm trying to make, is that when you're dealing with those control factors, now let me be more clear here. X1, X2 is really talking about the control factors or design solutions in your product. So how much do you know the variability? In most of the time, you may know because in specific, for example, say the material or design parameter by itself. But most challenging, like answering your questions, how much do you know the sensitivity? In most of the time, you don't know exactly how much sensitivity you have. And sometimes you cannot even distinguish differences. And using one very specific case study to answer your question, many times we did DOE, assuming you use the DOE design of experiments already. And then when we combine the noise factors and control factor, most of the time you found those troublemakers very sensitive, which with the significant impact for the performance. And really those things that could be the noise factors. So come to the point where is that way how you can be able to lay out those noise strategies and to minimize harmful side effects in the sense of optimizing the given control factors, meaning your design strategies. Did I answer your question?
Yeah, thank you.
Yep.
Thank you. We have also Adriano Adriano Lombardi, do you want to make your question, Adriano, or you can unmute yourself?
Sure, thank you. Hi, Professor. Just on one of the slides, it's just a quick question. There was one where you had input geometry on the x-axis. If you can just re-clarify what that was, because you had the shape. Maybe just another slide over. One more. I think it was a couple more down. It was further closer to the end. I'll go in. Sorry. Gonna keep on jumping all over the place. Yeah, right here on that slide. So you had, see on the y-axis, you have more of the form, shape, compactness. It was just that the input geometry, if you could just explain what that was.
Yeah. For example, say in this mechanical crimped connector design, the input geometry, for example, say the crimped height from here to here, for example, say, right?
Mm-hmm.
And also the area compressed. That's kind of input energy from a dimension standpoint, because that kind of the input geometry, that creates a kind of bonding force. When you crimp this one, then you create a kind of a very compact or compressed the kind of area. You see this one, if that the connector crimped properly, you don't see the gaps, voids and bubbles.
And so then the form shape on the left-hand side, is that the shape of the wires after being crimped? Is that what, what that means?
Yep.
Okay. Okay, I was just getting
That
confused.
is a compactness that we used to improve that the old design and also impose in the new design as one of the upfront design strategies. If we want to keep using the same technologies, we always guide the engineering group to consider this one of them. I look hard before talking about the reliability. Really, that the post ring is kind of downstream manufacturing or customer usage indicator. So in the engineering upfront design, we have to and better to we learn, unfortunately, later on that kind of there's a best practices upfront for these specific case studies.
Okay, thank you.
Okay, did I answer your question?
Yep.
Thank you.
Thanks a lot.
Thank you, Matt. Also, we have Andrew Doyle. You want to make yourself a question directly? Andrew Doyle, you can unmute yourself.
Okay, sorry, I was just having trouble unmuting myself. On one of the early slides, the part where you showed through design, concept design, development, manufacturing, and then later, and in there was the testing phase, and in that testing phase is when all these testings, like on that cable connector, would have been done later, but they would be, those tests are designed to match the spec of the material or the products. They're put into a chamber that's going to be a certain heat, a certain humidity. They're going to be vibrated. They're going to be dropped. They're going to be shocked. All this type of thing. Is that in itself, that those specifications and then that testing, in my mind, that's part of this robust design and specification. And is your point that those specs are too not narrow enough?
If I understand your question correctly, all you shared, I think, good efforts. And the question you're asking is that good enough or should be part of the efforts? So if I could answer this way, those things should be good exercise. And the one thing I'm not sure if you used, especially in the sense of robust design, in the sense of designing that kind of testing strategy, if you will, is that if you let me narrow down the discussion, let's talk about the testing first. So if you've been through those testing all the time from here to there per the specification requirements, and sometimes you get successful, sometimes you get pass and fail, right? So the questions that the upfront, if you by the way, assumptions that you may still get those the failure modes or whatever may be not meet your design requirement as kind of a minimum. So the questions that do you get enough or how much confidence you can get is that the upfront design, you always plan and design the noise strategies and also the develop the noise management strategies. That would help you to one stone killing many birds. One thing, to excite the failure mode. Secondly, you can provide those testing that you can be able to improve or increase your engineering confidence. Now that's talking about from a straight testing standpoint. The most important thing is that do you have a strategies or do you have a plan to optimize your design in the presence of the noise factors before you go any further testing? Does that make sense?
It does. It does, I think.
Thank you.
Okay. I think Matt, if you want to stop sharing.
Sure.
We can see our people now. Tony, do you want to make your comment? I think you shared something about that the industry is, and I think this is our concern, right, of all the quality professionals that sometimes on our companies, the industry is more focused on deliver, right? So I just turn control to you, Tony. You want to make your your question?
Okay. Can you hear me?
Yes.
Okay. Just it does seem to me that that there's a problem with industry in general and maybe society in general in that we understand reliability and robustness of design very well, but it almost seems like most of the products that are being produced today, they don't care. That the idea of getting the product to the market and getting it there before anybody else supersedes any thought of reliability or robustness in the product design. We have refrigerators that I was told by a repairman, gee, if you got one that's over 10 years old, hang on to it and keep it going, because all of the modern ones are going to not last more than 5 years. And this seems to be a general trend. It's a trend in software, where software comes out where the manufacturer absolutely knows that it will not deliver the specifications that they say for it. What do we do about that?
Absolutely, it's a good sharing, Anthony. So that is an ongoing challenge, but in the end of the game, it's always about business. And as what you were sharing, talking about the software development, that's talking about today's agile software development, right? But the idea is still good. But the challenge is when I say by meaning and, if we could be able to deliver the product with the highly reliable, the high quality, that's all we need. And in the sense of safety, reliability, like what I was sharing with the team here, is that the autonomous driving vehicles, you cannot afford not to have a safety, reliability. Like Uber testing failures that kill one person. So having said that, it's always the game change here, talking about the cost and the consumer confidence and also the reputation. So in the sense of automotive, the highly reliable expected, that means that we have the much more high requirements. For the commercial applications, for example, say talk about the internet, for example, at home, right? That's not high reliable and let alone about robust. I mean, not robust, let alone about reliability. So, having said that, we are certainly as a professional in the society, doesn't matter what field you are in, oil, gas, automotive, aerospace, or electronics, or technologies. It's really about, because no matter who you are, you whether you are the boss or you are the engineer, you always have to be providing your services at the highest possible quality of reliability. Now, what does that mean in specific? That actionable, operationable. That's really about the robustness in a nutshell. And for some reason, yeah, I am wearing many hats because in the technology company, I had to be a leader and I had to be an engineer. Then I had to work with my engineer to say, hey, make no mistake, deliver this product compliant to the automotive ISO 9000 requirements. You do it. But having said that, compliance is one thing, but how to take advantages compliant to work with the engineer to improve their engineering skill set on top of their engineering expertise, but about the reliability and robustness. I think that's a game for the strategies in that kind of working environment.
Yeah, I guess I'm just being very disappointed in society that we have today in general. But it's frustrating. I mean, you know, we've put so much effort into these things. We understand the technology and the solutions so well, and it just seems like it's not getting done. As a matter of fact, we're going backwards rather than forwards.
Well, it is the case. Unfortunately, well, I'll say fortunately that now we have the robust technologies, robust design mindset in the automotive sectors or aerospace. And unfortunately, that kind of idea is not very, very popular in the commercial applications. And also for somebody, the refrigerator, for example, say, I'm not, well,
Yeah.
I'm not saying they don't, but it's not very emphasized. All they talking about the reliability and design for reliability. As a matter of fact, I was having a discussion with one of my clients talking about, Matt, why don't you come here help and train my team for design for reliability? And that's a tool that I know well. For example, you say DFMEA and testing, Hall and has testing. I want you to be able to help me out, build the programs, and train them to do the job, and buy software and do a job. I said that what I was sharing with them is kind of not necessarily rocket science. If he knew it, then you can hire a person to do the job for a simple application standpoint. But really, what's missing in this conversation is the boss who does not know that kind of thinking. Yes. So how can the person can lead effort? Especially today, if you look at the job requirements, talk about quality reliability, talk about always compliance, right?
Yes.
And nothing wrong with that, because compliance gives you the standard you have to follow. But that's only give the minimum requirements. As for how to approach it, that's a different ball games. And one specific example talking about the IATF 16949, the automotive version for the ISO 9001.
Yes.
They're talking about the advanced quality planning process, almost similar, if you will, to the design for Six Sigma, or if you tailor to design for reliability. But really, do they have the thinking for your team to drive the effort? No, they don't. Because they did not tell you how, but truly, they want to tell you only what and give you a framework that you to comply with. But for how, it's up to you.
Yeah.
That's a challenge that society not have that kind of exercise. And especially in oil and gas, when I say oil and gas, we have a lot of good experts out there, don't get me wrong. But if you ask, do they know how to approach a robust design?
Yeah.
May not be the
Indeed.
case,
Yeah.
right? Medical device, for example.
Yes. Yep.
Well, thank you, Matt, Tony. I think, like you mentioned, I think that one good takeaway, we need to be leaders besides to be quality or engineering professionals, right? To really lead with our, be the leaders.
Yes. Yeah. ASQ has a whole section on uh, competent leadership, etc. And I hope we work with that, if you will. But thank you. I'm sure that was a very good discussion.
Yeah, that's why I'm so passionate today, excited to share the seminar topic where I delivered at least 3 times last year. One for the ASQ Liability and Risk Division, another one for the Automotive Group, and another one for the medical device private sections. I love it. And the question you may be asking me or challenging me, hey Matthew, great job, or if I did a great job today, so what will be the result that you can be able to demonstrate? That's exactly what I share with you today, talking about the digital transformation, successfully go through the robust thinking, through the lean behavior, and then deliver agile development. And today, whenever we talk about the product design or the process design or the continuous improvement, people always keep talking about agility, agile, lean, right? Without mentioning about robustness. The question challenge is that how can you handle it in the product upfront? You can't, or at least deficient.
Yes. Yeah, exactly. I think what you're doing is great. I just wish that instead of speaking to ASQ and the people who are already on board, I wish your message could get out to those people who are in charge of actually producing the products and whatnot, company managers and presidents and whatnot, so that we could actually get some traction on this.
Absolutely. As a matter of fact, I strongly recommend and encourage today's audience in this room take advantages to take the robust training either from ASQ or equivalent organizations or through the University of Houston. That's right in town of Houston area that I will be providing that kind of leadership for the technical training and also the engagement deployment strategies for the organization who wish to be deploying that kind of robust design strategies to improve their business in the sense of robust product, robust technologies, robust supply chain process, and also most importantly for the continuous improvements.
Absolutely.
I will invite everybody to turn on your unmute yourselves, turn on your cameras, and let's give a good applause to our speaker, Matthew. Very good job. Thank you very much.
Appreciate it.
Thank you.
I appreciate it. Enjoy it.
Thank you so much.
Thank you. And yes, great. We can keep here for a more couple of hours, right?
Hey,
yes, very
you
good.
very
Thank you, sir. Very
time.
informative.
Thank you very much.
Unless anybody wants to share anything, I think we finished the formal presentation, but I don't know if anybody wants.
I welcome all the questions and sharing or questions or challenges. I would love to share my side of experience. I love it.
Well, I got a question for the teacher. All right, so I know that from this presentation we will have an assignment about this, and I guess from the slides we can make a summary of what we learned and send it to the teacher as well, right, sir?
Absolutely, I can share my slides and what you hear. I mean, through the ASQ.
No. I was asking the teacher if there's gonna be assignment about this.
Oh yes, the assignment would be discussed more back to the class.
Okay.
Yeah.
All right.
One thing I'd like to point out, okay, this is just a quick note. You talk a lot of your hard skills, right? But in reality, you got to consider the soft skills, trying to work with the day-to-day operational floor members, right, to get involved. Yep. I mean, if you have all these complicated design for Six Sigma and all this, but then when it gets to execution, you don't have that leadership skills. I mean, try to incorporate that in part of your robust thinking, right? So
yes.
Just
well, very good questions and a really very challenging question. I'd love to share with you. Really is that when you are in an organization that's much more mature, then you can go a little bit more, assuming, let me put this way. If you have the program in the sense of a Lean Six Sigma or design for liability or design for Six Sigma, you have a better culture background, you can be much more easier, meaning that when you are given a project identified by the leadership or the current challenges from the market, from business, then you can take approach from a design for liability or design for Six Sigma project standpoint. You can always take that kind of approach and make a significant case. And that's exactly what I did when I was at Ford Motor Company. When I was a consultant, I helped organization, for example, Daimler Chrysler, where they had the wonderful traditional Lean Six Sigma program. But the challenge is for the leadership, they were asking us when we were deploying that kind of program, they say, are you asking me I did not do a good job? It's not the point. The traditional Lean Six Sigma, for example, is kind of reactive problem solving. But for the business, from the business perspective, it's very important to train those blood generation like engineers to learn the kind of skill sets. So we deploy and design for Six Sigma, deploying for the design for liability in the specific focus on the robust engineering, right? So now that's the ideal case, but truly when you are in the organization where we many of us here did not have that kind of a good environment, that means you have to start up from the bottom up. That when you're given a kind of the scenario, and then roll up the kind of sleeve and do the project. Certainly that the using the kind of the robust design approach. Now the question you're asking me, I'm new, I don't know, what can I do? That's exactly the point that the leadership come into the picture. I appreciate the kind of like University of Houston. They realize society needs and demand from the market standpoint. They offer that kind of training workshop. We can always work out with you in the sense of in-house training or deployment in a week or 3 days or 2 weeks, depends on exactly how you would like to make things happen in a certain way. So we offer the flexibility. So straight to your point, I think asking a very good question, certainly from a leadership standpoint, that boss need to be thinking hard. If you are burned with many quality reliability issues, you cannot afford to go back to the same traditional approach, which you know nothing about it. So why not give a chance to I'm not saying a new approach, but really kind of secret sauce for the people are in the advantages of solving problems through the robust design, but really there's a kind of upfront robustness thinking. It's a strategy. Because when you talk about the tools, people always come to you, hey, Matthew, I know that the tool one simulation, whatever maybe, those are good tools, depends on how you use it. Right? Even though they're not talking about the AI application, talking about machine learning, talking about the imaging recognitions, laser images. Those things, you can argue with the people, which is not the point. People say, I got the sophisticated technologies. But it doesn't matter what technology you're using, they have always deficiency, like digital transformation, digitization. Talk about machine learning, even not mature. Don't get me wrong, those are good trends. But really, when you come to a point, improve the current situation, or you are dealing with new products, we have to always be careful concerning about liability quality. But what will be the leading indicator for us? We know the traditional lagging indicator like a CP, CPK, and the data analysis, right? Which assumption that you have a big data already. But what can you handle it when you don't have data? when you're dealing with design. That's not the point.
I think you raised a good comment as well when you said they can't afford. I think when we're looking to get buy-in from senior leadership, sometimes going into the details, they get lost. And so I think making sure it can be translated into like, what's the cost implication, then it will get their
Absolutely.
attention. And if we can't do that, then we lose them to all the other noise they have to deal with.
Absolutely. A very good, if I could share my side story, when I was dealing with the high technology company, and I was in the headquarter quality office, and my job is deploying a kind of, we call it kind of design excellency, if you will, meaning focusing on the design efforts. And they realize they lose that kind of advantages when the product, when they came out to the product, the quality and the reliability was not attractive, meaning they did not have a good customer experience. So we come to a point, what would be the strategy asking me is that instead of doing the kind of traditional routine and kind of qualitative approach, the customer feedback, all kinds of things, which you know, that's why customer was not happy with that kind of product. As a matter of fact, it's up to you and me as a leader or being a truly executor, right? On the point, how to make something happening is much more in a different way. And robustness thinking offers a one action exciting approach to improve the technologies and the product where for it doesn't matter for current product or the new design. Very good question. Smith, from the leadership perspective, there are lots of issues. To me, is a kind of leadership education and sharing mentoring. One part of my responsibility is the sharing with the leadership in the C level and help them out solve the painful challenges because they are the one need to be responsible for the quality and reliability at the high level anyway. As for how it's up to you and me to share the kind of best approach or best practices in any situation.
Agree.
Thank you very much.
No, I mean, you make some very good points because, from my experience working with a company like General Electric, it's normally easier to, work through such kind of, high-level systems and high-level statistical applications. But then when you move to lower companies, much smaller companies, a lot of all your high-level knowledge, it then all translates to leadership skills and soft skills. So that's why, as much as we talk about, these high, robust, hard skills, always try to inject that, that element of soft skills there. That's what I'm bringing. And of course, you did cover quite a big piece of it.
Very good sharing. As a matter of fact, I was dealing with the General Electric application in both United States and China. They're emphasizing on reliability, but fail in the field applications. And in the traditional design, they follow the same old. I mean, don't get me wrong, they are very serious in the reliability efforts. They know what they should be doing at high level, but really there are points that they are not able to articulate exactly what they need before they reach the point about reliability. All they're talking about the heavy testing, heavy tight tolerance, and new technology, simulation, which is nothing wrong with that. I mean, you name it, we have it, we call it, we use all things, especially in the automotive design. That's very well applied. When I was helping one of my clients in China, when they were at the business at the bottom of 25, now they're up to the top 2 ranking in the wind turbine business. It's a superior, better performance than the performance in the United States. Certainly is better than the general GE performance. It's not something they don't know, but the leadership, unfortunately, they don't know that specific detail, the best approaches. Unfortunately, that's exactly what I was experiencing in person.
Yeah, good feedback.
Thank you.
Yes, really good. I think we are always looking for, we always, I always use consistency, right, for quality, but I think it's better to look for the robustness, and that is consistency